Have you ever wondered what that fuzz in your drink is? It's a phenomenon that is called carbonation. Let's talk about it. The chemical formula for carbonation is H2CO3 aqueous, which is an oxyacid and its name is carbonic acid. H2CO3 is called carbonic acid because it is an acidic compound. The anion for carbonic acid is CO3 which is called a carbonate ion. This is a polyatomic ion, and such ions with the suffix "ate" use the suffix "ic" as an acid. Carbonation is a synthesis reaction, also known as a combination. A combination reaction is basically A plus B equals AB, two elements that join to form a compound. This type of reaction almost always produces a gas. For example, leaving the cap off the carbonated soft drink allows the carbonic acid to release carbon dioxide. H2CO3 aqueous turns into H2O and CO2. This is a decombination reaction and the skeleton equation. H2O is a diatomic covalent bond because it is made up of two nonmetals. CO2 is a regular covalent bond because it is also made of two nonmetals. The word equation for carbonation is hydrogen carbonate. Here's a quick breakdown of the types of compounds in hydrogen carbonate. Hydrogen gas forms a diatomic covalent bond. Carbonate is a covalent bond because it is formed from two nonmetals, carbon and oxygen. These are the Lewis structures for carbonate and hydrogen. And also, this is the entire Lewis structure of the entire atom. As for balancing this equation is already balanced, and I'll show you how. So first we're going to write out our skeleton equation, which is H2CO3 turning into H2O and CO2. In the first part of this equation, there are two hydrogens, one carbon, and three oxygens. In the second part, there are also two hydrogens, one carbon, and we can see there is one oxygen in the first part and two oxygens in the second part, which equals 3. This means that the equation is balanced. Carbonated soft drinks are common in today's society. Many people across the world drink beverages such as Coca-Cola, Pepsi, Fanta, and Sprite, which are all carbonated. In fact, the entire soft drink industry makes about $500 billion a year, with the Canadian industry alone making $13.5 billion a year. The impact of carbonated drinks and bottled drinks alike are really harmful for the environment, as it produces a ton of CO2 and plastic waste. Not to mention, a lot of these companies have been notorious for underpaying their workers in poor countries, basically exploiting the people and draining the water in poor nations to create these drinks.
Hi guys, how are you guys doing today? So today I'm going to show you how you can make carbonated drinks. So basically we have to dissolve some carbon dioxide gas molecules into any water-based drinks. So this is simply water. So first what you have to do is just get a cup and try to squeeze a bit of your lemon here, not a lot but just a little bit. So you can collect this lemon juice and then you can try to pour it slowly and carefully into the water, okay? And then this is optional, but you can add some flavor. This is just lemon powder, flavored powder. So you can put some flavor in your carbonated water. You can shake it this, okay? And then all you have to do is try to get a little bit of baking soda. So maybe this much will be just fine. And try to add it very slowly. And as soon as you put this, you're gonna see the bubbles coming out from your lemon juice powdered drinks like this. So this is the image is simply is working. They're now making some carbon dioxide, but we're gonna use the high pressure. That's why you have to close the lid like this, and we're gonna put this in the refrigerator for about 1 or 2 hours because this carbon dioxide gas molecule will be much better dissolved in this water-based drink and at a somewhat cold temperature. So if you press this bottle, you can feel high pressure forming inside this bottle now, and this is working pretty well. So make sure you put this in the freezer for 1 or 2 hours at least. And this is kind of what I already done before. And now if you can see, just shake it. Shaking more. Let's see. See, this is quite well carbonated drink.
Thank you guys for listening to my presentation about the chemical properties of carbonation and its impact on the world and environment.